everybody, this is Brittany. Welcome back to my channel. A few weeks ago I put up a video called The Science Behind GMOs and said that that was the first in 3 videos. This will be the second of those 3 videos, The Myths of GMOs. So I highly encourage you to, if you have not seen that video, to just go back and see it. It's not that long, but it's going to give a lot of background that I think is necessary to understand some of what I'm going to say in this video. So I'm going to get right into some of these myths. While it certainly is a new technology, it's still really just a progression of what we have already been doing for thousands of years. In fact, the first instance of human interference with plants and plant genetics can be traced back to between 9,000 and 10,000 years ago. Of course, it wasn't until the work of scientists such as Gregor Mendel and Charles Darwin until we had a better understanding of genetics and how selection functions. So obviously those first attempts 9,000 to 10,000 years ago were probably pretty primitive, probably just humans selecting traits that they like, putting the plants close to each other, hoping that they'll breed. A little later in history, we learned a bit more about how to hand pollinate, how to ensure that the 2 plants that we want to breed are breeding. And now when you go to catalogs of, say, heirloom seeds, you can find numerous varieties of different plants that have been bred long enough that their strain has become stable, which means that every time you plant the seed that comes from the plant, you'll get the exact same plant. My point is that humans have been messing around with plant genetics for a long time, and the fact that we've just changed our technology a little bit, while certainly it's worthy of skepticism and scrutiny, it should not be perceived as something that we've never done before. And in fact, something I'd like to leave you with as something to think about is the fact that when we think about selective breeding, where we're just putting kind of 2 plants together, we're maybe hand pollinating, and then we're taking the seeds and planting those again and then selecting the ones that we want to breed because they have the desirable traits. There's a certain amount of chance to that, right? We don't necessarily have total control over what genetics are ending up in the different offspring. We don't have control over what genes are coming along with the desired genes. So we may be selecting for a particular gene for a particular trait that we want, but what we might not see is another trait that is coming along with that desired trait. And so really selective breeding is quite imprecise. Now we look at genetic modification and we have a technology that is extremely precise. We can decide exactly what trait we want. We can find a gene that will code for that trait, and then we can insert it into the genome of the plant that we want to have that trait. It's very precise, and you could almost make an argument that, you know, perhaps it is a little safer than selective breeding because you know exactly what you're going to get. You're not hoping that you won't get a whole bunch of other traits that you didn't want. So, of course, I'm not saying for sure that it's safer. I just want you guys to think about that. I feel like this is never totally articulated. People are just kind of, they're concerned about GMOs and they have trouble specifying why. But as you talk to them, you get the idea that, you know, they have this fear that by inserting a gene, it's somehow going to screw up the rest of your genes. And this is the myth that it's super important that you watch my first video for, because I give you reasons why that's impossible, because these genes do not interact with each other in the process of DNA transcription and translation into the eventual proteins. When those happen, each gene that's translated in protein that process is completely unique from other processes, and it is literally impossible for there to be any interaction between the inserted gene and the other gene, or the inserted gene and the proteins that are being translated from other genes. Like, the process of DNA transcription translation does not allow for that to happen. What a lot of people talk about is that in certain GMOs, the gene that's being inserted has been taken from a bacterium genome and inserted into the plant genome. And so a lot of people worry that, oh, you know, it's in a bacteria, you know, you shouldn't put bacteria DNA into plant DNA. And I mean, there's a certain aspect to that that's kind of ethics based. You know, should we be putting DNA from one type of creature to another type of creature? And that's, you know, not my purview. That's ethics. That's totally different. But I do want to say that chemically speaking, DNA from a bacterium is the exact same as DNA from a plant in terms of what it's composed of. All the kind of molecules and cell machinery and everything are going to recognize that inserted gene as if it were a plant gene. Cell machinery can't look and go, ooh, I know this came from bacterium. No, it doesn't work that way. That DNA that came from the bacterium is going to be composed of nucleotides, just like I talked about in my science video, the exact same stuff that the genes from the plants are made up of, and thus they are going to be read the exact same way that a DNA from a plant would be read. So according to the cell that is dealing with that DNA, it doesn't matter that it came from a bacterium, it's just DNA. And this actually sort of goes into my next myth, which was brought up to me by a fellow YouTuber by the name of Trollforge. I'll put a link either in here or down in the description. Sugar, or at least the white sugar that we typically use in our baking or whatever, is only composed of one molecule that's just, you know, constantly repeated and bonded together. And again, that molecule, regardless of where it comes from, is the exact same. You see, because whether it's coming from sugar beets or sugar cane, which is the kind of organic source, the process of making sugar is isolating that molecule from the rest of the sugar beet or the sugar cane. We now have such an advanced isolation process for sugar beets and sugar cane that even when examined under a microscope by scientists, the sugar that came from the GMO sugar beets was indistinguishable from the sugar that came from the sugar cane. That means that when we eat it, our body is going to have no idea that one came from a GMO sugar beet and one came from sugar cane. Molecularly speaking, if it's the same, then our body is going to react the same. You might find it interesting that I said both less and more. That's because those are claims coming from both sides. GMO proponents are saying that, oh, GMOs will cause us to use less herbicides, whereas anti-GMO people are saying, oh, it'll cause you to use more herbicides. And I mean, I could go into those specific claims, but what I really want to say is that I'm using that particular idea as kind of interchangeable with any claim that's like, oh yes, GMOs are going to do this, or yes, GMOs are going to do that. The simple fact is that genetic modification is a technology, it's a process, it's not a function. You can't make these grandiose claims about the function of GMOs. In every individual case of genetic modification, there's a whole bunch of different factors at play. What plant is being genetically modified? What is the inserted gene? What is the purpose of the inserted gene? Where is the plant going to be grown? All these things. And so you really can't say that all genetically modified organisms are going to cause this or are going to lead to this, No, every individual case is going to be different. And this brings me to my last myth. This is a myth that I've bunted up against many times due to being in the gardening community and loving gardening and ordering seeds from different catalogs. I do personally like to grow heirlooms for reasons that I'll talk about in my next video. And I've seen a lot of these companies now saying, oh, GMO free, certified GMO free, you know, there's no GMOs in our seeds. To be blunt, this is a marketing ploy. If you are ordering your seeds and you don't want to grow GMOs for whatever reason, and you see one company says GMO free and the other company doesn't, you might be inclined to go for the company that says GMO free, and I would caution you against that. The truth is that consumer seeds, so seeds that are sold to the average person, are never GMO. They just aren't. First of all, there are very few GMO crops, and it's mostly those crops that are grown in humongous fields. So these seeds are only ever sold to kind of the big time farmers, right? If you're an average person with like a little garden, even a bigger garden, but you're ordering from a seed company that tends to sell, you know, the small little seed packets, you're not going to get GMO seed. So when these seed companies are saying, you know, GMO free, it really is marketing. It really is them trying to get the upper hand over other companies that maybe don't realize that there's a large swath of the population of gardeners that have been falling prey to some of the myths that I've talked about in this video so far, and so have in their minds that, oh no, GMOs are bad, you know, I need to make sure that none of my plants are GMO. So I hope you found this video informative, and I hope you'll keep an eye out for the third and final video in this series, where I'll be talking about my general thoughts on the subject of GMOs, and I'll also talk a little bit about what I think about the whole GMO legislation thing. So if you're not subscribed yet, I highly recommend that you hit that subscribe button so that you won't miss the video. And if you like this video, please give me a thumbs up. If you have any questions, please comment below and I'll try my best to answer them. And I'll see you in the next video.